Okay, here we go. We're going to focus on substitution. And so basically, we're looking at a system of equations, which just means that we have two equations together. I'm tripping over my mic wire. All right. And so when you're given two equations and they ask you to solve it, they're basically saying, hey, when do these two equations, if we were to graph them, when do they intersect? uh, what's X and what's Y? What X and what Y do they both share? And so we've graphed, right? And now what we're going to do is we're going to solve a system algebraically. And so what does substitution mean? I don't know if you've ever cooked, but sometimes if you cook and let's say you don't have, you realize, oh, I don't have any oil, you could substitute in butter, or you could substitute in something like yogurt, something like that. So what we're going to do is we're going to substitute kind of similarly, but here's the deal. See how y is equal to 6x? That means we're not just doing oil and yogurt, because those two things really aren't equal to each other, but y is really equal to 6x. And then over here, y is really equal to negative 4x minus 50. And so we want to see, well, hey, when do the y's in both of our equations, when do they equal each other? So what we're going to do is this. We want to say basically, hey, when does y equal y? And so we can't solve that because it's like, well, what? We're going to subtract the y. We're not going to get anything. So instead, let me get rid of all that orange. What we're going to do instead of saying y equals y, we're going to say, well, if this y equals 6x, then I'm going to put 6x equals, if this y equals negative 4x minus 50, right? This is a way of saying y equals y. When does y equal y? But instead of y equal y, because we can't solve that, we can actually solve this, right? And so let's go ahead and let's bring the negative 4x over. Let's add 4x to both sides, and we'll get 10x, right? That's gone. Bring down the negative 50. Don't forget that negative, right? Divide both sides by 10, and we get x equals negative 5. Now, what does that x equal negative 5 mean? That means that both equations, when x equals negative 5, y is going to equal the same thing in both equations. So I'm putting the negative 5 here because for delta math, right, that's our x value, and that's our y value. All right, so now how do we find our y value? Well, we want to know, hey, what is y equal to when x is equal to negative 5? We can pick either equation. If we pick this equation, y equals 6x, all we do is we plug in a negative 5 for x. We pick up our calculator, and that says y equals negative 30. Now you're probably saying, and so there's our answer for y, right? Y is equal to negative 30. Before we would hit submit, I want you to understand, we could have picked this equation too. Now let's go ahead and do it. Do we have to do it too? No, we don't. But I want to show you something. If x is equal to negative 5, that means that, see how here's my x right here? I'm going to, instead of writing an x, I'm going to plug in the negative 5 and then write the rest of it. And if I put this in a calculator, I get 20 minus 50 is equal to negative 30. So I get the same answer. All right, I want to stop for just a second because I realized I just flew through something that I think is a hard concept, and that's this whole we're allowed to just plug something in. So let's go back and talk about what we just did. See this y equals 6x? We're saying, hey, x is x is just a stand-in for a number. And what we're going to do is take the x and we're going to get rid of it. And instead of writing x, we're going to plug in that negative 5, all right? And when we plug in the negative 5, I always say the plugging in, they come in with their parachute, and their parachute's coming in around them, right? There's another way to do this. If you don't like plugging things in, here's another way to do it, okay? So it feels like, oh, I'm just making the problem longer. I'm just giving you options. All right, let's do options in pink. Remember our calculator when we hit the table function, right, the table button? We could do the same thing here. We could hit the table button and then hit enter, 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 all those things, and hit y equals 6x. I think the y equals is already there, right? We'd have to put 6x in. Then we'd look at the table, right, and we'd see, hey, when x is -5, what is y? And what would we see? We would see -30. So if you don't like the plugging in, you could do the table function. All right, lots of different ways to do math. We'd hit submit, and we would get our green check. All right, there is another type of substitution. And so this substitution is where they give us, they say x equals -5y. So what I'm going to do is I see, wait a minute, over here is an x. If I go ahead and rewrite this, hopefully you can see this pink. If I rewrite this and say, wait a minute, right now I have an equation with both x and y. But if I took, instead of writing x here, if I plugged in -5y, which we'll do, we'll go ahead and take away the x, and we'll plug in a -5y. Then look, I have an equation with just y's, and I can solve it. Let's go ahead and add our like terms, -5y minus 6y. That's going to give me my -11y. And then I'm just going to divide both sides by -11. And I get y equals -2. Now we have to be careful. When we solve for y first, we want to put it where the y goes. All right, don't put it where the x goes. All right, so now we need to solve for x. So I gave you the table function, and you know what? That works sometimes, and sometimes it doesn't. So we're actually going to have to get used to just plugging things in, I think. So we can use either equation to find x. But you know what? This equation right here is easier. So let's go ahead and rewrite it. X equals -5y. And we're like, hey, we know what y is. Y is equal to -2. Now we can't use a table function here in the calculator because this equation starts with an x equals and not a y equals. And we can't do that on our calculators. Bummer. But here's what we can do. We see an x, we write an x. We see an equal, we write an equal. We see a -5, we write a -5. But when we see our y, we're going to take that y and we're going to throw it away. It's going to be gone. And in its place comes parachuting down -2, right? Because it says right here, y is equal to -2. So we go ahead and substitute that in. We pick up our calculator. -5 times -2 is 10. So if we were graphing these, because we already know how to solve an equation, solve a system of equations graphing, our two lines would intersect at 10, -2. But now we can do it without graphing. It may seem harder, but it's important to be able to do both ways, because if you, let's say you want to be an engineer and you go on and do calculus, and you got to do calculus in college, believe it or not, we do systems. We solve systems in calculus. Like, you actually need to know this. All right, so this is level 2. I think it's the same, so level 2. So level 1 was the easiest. Level 2, we've got 2 problems. And so let's do this. I wonder what's the difference between these two. Oh, I get it. This one was an easy plug-in. All right, we can do this. So see how we have x equals -3y? These two things are the same thing. So what we're going to do is we're going to plug in. We see an x here, and we're like, you know what? If we got rid of that x and plugged in -3y, then our equation will just have all y's, and we'll be able to solve it. So let's rewrite this equation. And here we go. See how we've got, we're going to take our x, we're going to take it, we're going to throw it away. It's gone. All right, so I'm going to rewrite this equation. I'm going to see the -6, I'm going to write the -6. And in comes the -3y, parachuting in to replace the x. And so its parachute kind of falls on both sides of it. And then we're going to rewrite the rest of it. I see a minus, I write a minus. I see an 8y, I write it. I see an equal. And you're like, wait a second, Miss Overby, we did not need a parenthesis when we plugged in the x. And you're absolutely right. Remember when we took this x and we threw it away? And in came the -5y. The parentheses weren't there. Now, We could have used parentheses. Parentheses are, they're not bad. But there was nothing in front. See how the x was by itself? There was nothing in front of here. We didn't need parentheses there. It's kind of like protecting it, but also just knowing that, see how the -6 was there? When we plug in that -3y, we have to use parentheses because parentheses, when you're next to somebody, means multiplication. All right? So hopefully that made sense. So here we go. Let's work on this side. -6 times -3y. Well, -6 times -3 is 18. And then we just rewrite the rest of the equation. And then we're going to combine like terms on this side. 18 minus 8 is 10. And then we're going to divide both sides by 10. Good thing we know how to solve equations because lots of that going on. Y equals 5. We're going to be really careful that our y answer goes into the y part, not the x. All right, man, I wrote big. All right, let's do a bright, let's do fluorescent green. So now we want to solve for x. Let's pick this equation. X equals -3y. We know what y is. Y is 5. 5 is going to come in and parachute in. But first we have to take y and throw it away. Woo, you're gone, y. All right, let's rewrite the rest of it. And in place of y, in comes the 5, parachuting in. And so then we pick in, we pick up our calculator. -3 times 5 is -15. Once again, if we were to graph these two equations, this is where the two lines would intersect. -15,5 is part of both of these equations. It's the only point that's part of both of the equations. All right, I think this is our last one. We can do this. Oh man, this is a lot, right? So I see the y that's alone. That's my thing to say, okay, instead of writing y, I see a y here, I see a y here. Instead of writing y here, because you know what's going to happen, we're going to throw that y away, I'm going to have to substitute in all of this. This is the first time we've had to substitute in a lot. But we can do it, right? So let's go ahead and rewrite this equation here. So we've got -9x minus 10y equals 12. Hope you appreciate this very bright green. So we're going to, since y is isolated, that's why we're going to choose to pick y and pick it up and throw it away. And in its place, right, we're going to put in the -3x plus 3. So let's rewrite. I see a -9x, I write it. I see a -10, I write it. We threw away our y, and in comes our -3x plus 3 in its parachute. And so now, do you remember our first unit where we solved equations? This looks just like it. Who knew that we were actually preparing ourselves to solve something like this? All right, so what are we going to do here? Remember what we did? We actually took, let's do it like this. We actually took something and we blocked off the first part. All right, we're going to block off the first part, and we're going to go ahead and act like it's not here, okay? So we're going to go ahead and distribute. -10 times -3 is 30, so we have 30x. -10 times 3 is -30. Bring down the equal, bring down the 12, and then say, well, actually, the -9x is there. And so what that means is we bring it down. Now, so bring the -9x. Now, what goes in between these? Well, -10 times -3, that's a positive 30. All right, and now all we have left, right, we're going to add our like terms, right? So we're going to go ahead and say -9 plus 30, that's 21x. And then we just have a two-step equation, right? We're going to add 30. Bring down the 21x, that's 42. Divide both sides by 21, and we get that x is equal to 2. So we're going to put the 2 in our x spot. All right, now, man, what a mess, what a mess. Can I get rid of all my work here? Because I don't have any space to work, so I'm just going to get rid of it. Bam, gone. Okay, whoops. Wait a second, what's our answer? 2. Okay, get rid of it and put the 2 for the x, right? Okay. Let's switch colors. Let's go to something that we haven't used yet. I don't know. How about this? Rust. Ooh. All right. So we have x. We can pick either equation. If I plug x into this equation, or I plug x into this equation, it doesn't matter. We're going to get the same answer for y. Honestly, this looks easier, and I'm always going to pick the easier one. So I'm going to rewrite this, and I'm going to plug in my 2. So when I see x, I'm going to take the x and be like, you're gone, throwing you away. And then in its place comes the 2, parachuting in. Then look at this. I can just pick up my calculator and put that in my calculator. I'll get what? -3. And we're done. That's my y. All right. Now, hopefully you're actually listening to these videos, because as the math gets harder, it really does help to hear me teach it. All right. Thanks for joining me. Please ask questions in class. See ya.